Hello everybody, my name is Sharon George and today I'll be explaining a program to you. Today's topic is sorting and we are going to look on merge sort. First of all, I have made a program here in CodeBlocks, but before going on to the program, let us have a short introduction about merge sort. So we use merge sort because it has a very interesting running time in comparison to all other sorting methods. It has a running time of big O of n log n, which is much less than other sorting methods which have big O of n square as their running time. That's one of the biggest advantage of merge sort, and that's the reason why we moved on to merge sort. Another thing is that according to the methods used in merge sort, we'll see how it is a big O of n log n, but it has got a space complexity of big O of n. So that's one kind of disadvantage because you're using extra space while sorting. So what you actually do in merge sort is that you have an array and you divide it into two parts. So you have two sub-arrays now. So now you sort this array and this array together. You've got two sub-arrays. Now you sort those two arrays and then compare each elements of those arrays and put them back into the new array, the newly created space. So because you're creating a new array in which you're putting the sorted elements one by one, that's why the space complexity is big O of n. Okay, so now let us move on to the program. So you begin by including the header file in the standard library file. I've used conio.h here because there will be certain functions used from this header file. Okay, so I have two functions. One is merge and the other is merge sort. I have just declared merge here, which says void merge. It has four parameters to be passed inside merge. Int star a, that is we're going to pass the array. Int three more int parameters. We will come to know what those three integer parameters are while defining the function. Then our main function is merge sort. Inside merge sort, I will pass, here I'm not declaring it, I'm defining it and declaring it together. So int star a, that is we're passing the array, int low and high. There are two integer variables known as low and high. Low will be the initial part of the array and high will be the ending part of the array. So we're going to pass these three parameters inside the function. So inside the function we can see I have declared a variable called int mid. Now what is this mid? First of all, this whole if condition, everything inside if will run if this if condition is true. That is low is less than high. You have an array and the low begins from the left part and high is on the right part. As long as low is less than high, this part of the code should run. So what is mid? Mid is low plus high by 2, and inside merge sort, since it's a recursive function, you will call merge sort twice inside the merge sort function. How you going to how these two functions differ? The different parameters. So you pass the array, then you pass low and mid. That is, you have divided it in the mid position. So from low to mid, and then from mid plus 1 to high. That's how you divided it, and that's how you will pass the parameters inside the merge sort function. I hope you understood that. You had an array from low to high. You divided it, so you got a mid position. So you start from low to mid. The next array will be from mid plus 1 to high. It's simple. After that, you call the merge function. Now the purpose of the merge function is, as I told you, you will separate your given array into two, divide it into two sub-arrays. Now you have to combine it back into single array in the new space. Okay, so that you use merge function. So what all am I passing? A, the three integer parameters are low, high and mid. This order shouldn't be wrong. This is the way you're going to pass it. If this condition is not true, low, less than high, you just have to return. Now I'm going to define merge function. Now this is very important. You need to understand this. Okay, so void merge. I have passed three integer variables here. One is array, then low, high, and mid. So I declare three integer variables I, j, k, which are loop variables, and the new array. The space complexity is big O of n because I'm creating a new array here. I'm using an entirely new space which was not earlier given to me. So that's the only disadvantage of this sorting method. So I is equal to low and k is also equal to low. I is for I is for one subpart of the array. K is the coordinate for the newly created array, and j is for the second subpart. So these are all the lower coordinates of those three arrays. So while I is less than equal to mid and j is less than equal to high, if this condition is true, what you have to do is you have to check if a of I is less than a of j. If a of I is less than a of j, what you have to do is you have to place the value of a of I, copy the value of a of I into c of k, which is the newly created array's position, and increment k and I. Now this is simple. You need to understand, once you will compare, if which one is less, you're going to place that first in the new array and then increment the new array's position, because if you have put the element in c of 0, then you have to increment it so that k becomes 1, so the next element can be inserted. And I also, because since one element of I has been inserted, now you have to check for the second element, so increment I also. Else, if this condition is not true, in that case, that means a of j will be less. In that case, place a of j or copy a of j into c of k and increment k and j by 1. Next while condition, if I is less than equal to mid. If I is less than equal to mid, in that case what you have to do is copy the value of a of I into c of k and increment k and I. Okay? Or if j is less than equal to high, in that case just copy the value of a of j into c of k and increment k and j. Now just a small loop you'll run, I equal to low till I less than k and I plus plus. Just copy all the values of c of I into a of I. That's it. So you end there, and now I begin with the main function. I've initialized my main function. Since it's int main, I've given return 0 at the end, and int n, this is an integer variable for the maximum size of the array. As you can see, I've declared two array here, a of n and b of n, and a loop variable I. And now I will ask the user to enter the variables using the for loop. And now I call the mergesort function here inside main function. Now this is how I'm passing the parameters, the arguments. First, since I've created an array called a, I've passed a, and this will be low and this will be high. And this for loop is used for displaying the array elements. And that's it. So I had used konya.h here because I was using this get ch function here. Even if you don't use it, it's fine. So let's just build and run and try to see it. Enter the maximum size of the array. So if I enter 5, enter the elements. Okay, so 23, 1, 2, 22, 78, and 1. Okay, so the thing is, there is no space, so we can just put some space. Okay, we'll build on it and try to see it once again. Maximum size is 23, 22, 21, 56, and 1. So the sorted array is 1, 21, 22, 23, and 56. You can see that. Okay, so that's how you use mergesort. I hope you understood. You can also try it once again with the second thing. So if I enter 5, 4, 3, 2, 1, the sorted array is 1, 2, 3, 4, 5. The one problem is, again, here also you don't have space, so you can just put a space here. So this time when I run it, 5, 4, 3, 3, 2, 1, and again if I enter 7, 7, 6, 5, 4, 3, sorted arrays 3, 4, 5, 6, 7. So that's it. I hope you understood the mechanism of mergesort. The only thing that you need to remember is the advantage of mergesort is that it has got a running time of big O of n log n, which is much less in comparison to other algorithms. And the only disadvantage is we're using an extra space, which is not given to us. So you have a space complexity of big O of n. Thank you.